Have you ever, stopped to think about how much of what we call reality is actually, out there in the world versus how much is shaped by our own senses? It's
Hmm.
like kind of a mind-bending question.
Oh, absolutely. You start pulling on that thread and who
Yeah,
knows where you end up.
exactly. And speaking of going down the rabbit hole, that's what we're doing today with Ernst Mach, actually.
Yeah, Ernst Mach, he was a fascinating guy. I mean, he really crossed boundaries, like born back in the 19th century, and he was making waves in physics, things like supersonic motion and the Doppler effect, that was him. But then he was also this incredibly influential philosopher. Like
Wow.
even Einstein gave him props for kind of paving the way for relativity.
Yeah, that's right. And what's really interesting for us, for the philosophers listening in, is that, well, he wasn't just dabbling in philosophy, right? He was a professor of the philosophy of the inductive sciences. But even more than that, his philosophy was like totally intertwined with his work in psychology.
Totally. He looked at how our minds actually work, and that kind of shaped his whole view of knowledge and reality.
So, mission for today's deep dive is to really unpack these core ideas of Mach, especially for a philosopher like you listening. We're going to focus on his brand of empiricism, how he was skeptical of metaphysics, the whole elements thing he came up with, and how he understood perception, all this stuff. We're going to be diving into excerpts from the Stanford Encyclopedia of Philosophy entry on Mach. Great overview of his work.
It is. It really gives us a lot to chew on.
Okay, so empiricism.
Yeah.
We all know the basics, right? Knowledge comes from experience, from our senses. But Mach kind of put a unique spin on it, didn't he? He brought evolution into the mix.
He did, big time. He was an empiricist, sure, but not like John Locke with the whole blank slate idea. Mach something was the biologized a priori. So for you philosophers out there, this is where things get really interesting because it's like he's taking what Kant saw as pure reason, these inborn categories of understanding, and he's saying, nope, that's actually, it's the legacy of our
Yeah.
ancestors. Like it's their experience, their interactions with the world, kind of baked into our mental hardware.
Whoa, that's a wild way to look at it. So
Yeah.
it's not that we're born with these mystical categories in our heads, but they're more like inherited wisdom, right?
Mm.
Passed down from generation to generation.
Exactly. It's evolution shaping the way we understand the world. So Mach thought that like even the earliest organisms, their simple experiences, they kind of started to structure the way they perceived reality. And over time, over like tons of evolutionary time, those structures that helped them survive, they basically became hardwired.
Yeah.
And that's what we experience as innate, as a priori. But really it was learned a posteriori by our ancestors. Like through this whole process, both evolutionarily and even within an individual's development as we have our own experiences.
So it's like our brains come preloaded with these programs,
Yeah.
but they're not like from some abstract realm. It's from the challenges our ancestors faced
Right.
trying to survive.
Right. And this really puts him in an interesting spot in the whole nature versus nurture debate.
Yeah.
Because he's emphasizing this kind of nature, but it's not totally dismissing the role of experience.
Right, and it definitely puts him at odds with Locke and that blank slate idea.
Oh yeah, he was much more aligned with someone like Ewald Hering, the physiologist. Hering had these nativist ideas, really different from someone like Helmholtz, who was more of a strict empiricist when it came to how we perceive things.
Makes you think, doesn't it? Like we're not just passively absorbing information, right? Our biology, it's actively shaping how we see the world.
It is. It really is.
So let's move on to another big theme in Mach's thinking.
Hmm.
His aversion to metaphysics. He was pretty vocal about it, right? Anything
Yeah.
that couldn't be directly verified through experience, he was just like, nope, not interested. So how does that connect with positivism, with that whole philosophical movement?
Well, Mach was definitely a critic of metaphysics, that's for sure. And this ties in closely with the verifiability theory of meaning. The idea is that for something to be meaningful, for a statement to really mean something, it has to be possible to test it, to verify it through experience.
So no armchair philosophizing allowed, right?
Right.
You got to get out there and see if it holds up in the real world.
Exactly. But, when we call Mach a positivist, we got to be careful with that label because positivism itself, it's actually a pretty complex and diverse tradition. And the way we understand it today, it's not necessarily how it was understood back in Mach's time.
So it's not as straightforward as just slapping that label on them.
Not at all. And today, sometimes positivism gets like a negative connotation. But back then, I mean, he was considered a positivist, but he was more aligned with thinkers like like Husserl and William James, than with Comte, who's often seen as the quintessential positivist.
Interesting. So his rejection of metaphysics wasn't just like some kind of abstract skepticism.
No, not at all. His scientific phenomenalism, as it's sometimes called, it wasn't just doubt for doubt's sake. It came directly from his work, in psychology, from his understanding of evolution. He really believed that our knowledge of the world, it has to be based on our experiences, on our sensations. And that's shaped by our biology, by our evolutionary history. So metaphysical claims, a lot of the time, they just went too far for him, beyond what we can meaningfully experience or test.
That makes sense. So that brings us to his idea of elements. This seems like a key part of how he tried to like bridge the gap between the physical world and the mind. So what are these elements exactly, and how does this all connect with his philosophical goals?
Yeah, the elements, they're central to Mach's thinking for sure, and he was influenced here by Gustav Fechner, the guy who pioneered psychophysics, studying how physical stimuli and our subjective experiences relate to each other. And also, Avold Haring's ideas played a role. Basically, these elements they're like the building blocks of both the physical and the mental. Think of it like raw sensory data, a patch of color, a sound, a feeling of pressure.
So they're not like physical objects in the traditional sense, and they're not just mental states either, right?
Yeah.
There's something more fundamental.
Yeah, that's the idea. He was trying to go beyond that classic dualism. So Mach, he envisioned this kind of scientific monism, this idea that both the physical and the mental, we can understand them using the same scientific methods. And it all starts with these shared elements. He saw the physical world as having these stable, measurable relationships between these elements in the mind. Well, that's just different configurations and associations of those same building blocks.
That's pretty ambitious.
Yeah.
It's like he was trying to tackle the mind-body problem head on, but through science.
Yeah.
And while he talked about these elements in terms of sensations a lot, was that the whole story for him? Was he just a sensationalist?
Well, not completely. I mean, his early formulations definitely had that strong emphasis on sensory experience, but Mach himself, he acknowledged that you could approach it from other angles, even a materialist perspective.
Yeah.
He even mentioned like Richard Avenarius, who was more of a physicalist. Mach saw similarities between their views.
Yeah.
So the exact nature of these elements, it wasn't like set in stone for him. It was more about the overall goal, finding a way to scientifically understand both the physical and the mental and how they come together.
Makes sense. So now let's talk about perception. One of the really cool things about Mach's work is his discovery of Mach bands, right? These visual illusions. And they tell us a lot about how we actually experience the world, as embodied beings. Can you break that down for us a bit?
Oh, yeah. Mach bands, that was a huge discovery. These illusions where you see these bands of different brightness at the edges of a gradient. They show us something really important about how our visual system works. It's not just passively taking in light, right? It's actively processing information. It's emphasizing contrast, the relationships between different inputs, not just the absolute levels of stimulation. And this led him to the idea of lateral inhibition. It's like this process where one neuron, in our sensory pathways, it actually inhibits the activity of its neighbors. And that basically sharpens the boundaries and differences that we see.
So it's like our eyes, they're not just cameras, right? They're doing all this pre-processing, highlighting changes, contrasts, and maybe not caring so much about the uniform areas.
Yeah, exactly. And Mach argued that this relational nature of perception, it's not like a bug, it's not a flaw, it's an adaptation. It's something that's helped us survive. He asked this thought-provoking question: how could we even function if we only saw absolute levels of illumination? Like, imagine a cloud passes overhead. Suddenly, everything looks different. But by focusing on relations and contrasts, we can see edges, we can pick out objects, we can survive in a world that's constantly changing.
Yeah, that makes so much sense when you think about it from an evolutionary perspective, right?
Mhm.
And we got to be able to detect change, to know what's a threat, what's an opportunity. And this whole idea of relational perception it connects Mach directly with Gestalt theory, right?
Oh, absolutely. Mach is seen as a major forerunner of Gestalt psychology. Christian von Ehrenfels, the guy who founded it, he straight up gave credit to Mach's book, The Analysis of Sensations. It was a big influence on him, and you can see why. Mach's work on things like Mach bands, it showed that our minds, they're not just passive receivers, right? They're actively organizing and structuring what we experience. He used this great example of recognizing a melody. You know, you can recognize it even if it's played in a different key or at a different tempo. What we hear as a melody, it's not just the notes themselves, it's the relationship between them. And that's the core of Gestalt psychology. The whole is greater than the sum of its parts. We're perceiving relationships, not
Yeah.
just isolated bits of information.
So cool. It's really amazing how much Mach's thinking was grounded in biology and
Yeah.
evolution. He didn't see science as this separate thing, like just some intellectual pursuit. He saw it as deeply connected to our biological needs.
And that's a really important point about his philosophy of science. He saw it as a continuation, like a direct continuation of how humans and even animals adapt to their environments. He traced this line from simple reflexes, you know, the automatic responses we have to things in our surroundings, to the development of memory, which lets us be aware of spatial and temporal relationships. And then that individual memory, it expands into cultural memory, you know, knowledge passed down through generations. And for Mach, science, it's the peak of this whole process. It's adaptation, but done consciously and systematically.
So from like a reflex to pull your hand away from a hot stove all the way to complex scientific theories about the universe, it's all part of the same story, right? Organisms trying to make sense of the world, to survive.
Exactly. He saw this seamless progression from those unconscious adaptations to the kind of conscious methodical adaptation that we do in science. And he even had this teleological view of science. Like he thought it evolved to take over for those earlier, less reliable ways of adapting.
So if we're thinking about the purpose of science, looking at it through Mach's eyes, it's not about finding some objective truth that's out there, independent of us.
Not for Mach, no. For him, the real goal of science, the biological goal, is to give us the best possible tools to orient ourselves in the world, to understand where we are, what's happening around us. If a scientific theory doesn't help us do that, then in his view, it's kind of missing the point.
And this whole orientation thing, it leads us to another one of Mach's big ideas,
Mhm.
the economy of science. It sounds like it's about being efficient, being simple in how we explain things. So how does that fit with this biological purpose of science?
Yeah, so Mach's principle of the economy of science, it pulls from both biology and economics. It's this idea that science should aim for the simplest, most efficient description of nature. And the reason for that, it goes back to that biological purpose. If science is supposed to help us orient ourselves, then if theories are too complex, too convoluted, they actually get in the way.
So a good scientific theory, from Mach's perspective, it's not just accurate. It's also elegant, right? It tells us a lot with as little extra baggage as possible.
Exactly. Uneconomical theories, they can't do the job. They can't help us orient ourselves effectively. He saw science as a way of saving experiences, you know, being able to anticipate what's going to happen based on what's happened before. Both our own memories and the knowledge we've gained as a species through science. And by having these economical theories, we get better at predicting, at responding to the world, which helps us adapt and survive.
Makes a lot of sense. And this drive for economy, it also played into his desire to see psychology and physics, to see them unified, right?
Oh yeah, definitely. Mach saw the separation between them as kind of artificial and more importantly uneconomical. You know, if you're trying to understand the world, to get a unified picture, having these separate frameworks for the physical and the mental, it doesn't make sense. It's inefficient.
Yeah.
It gets in the way of that basic biological task of science. And he thought that his idea of elements, you know, those shared building blocks, that could be the foundation for this unification, a more economical way to see how experience in the physical world, how they're all connected.
So fascinating. Okay, switching gears a bit, let's talk about how scientific knowledge changes, how it evolves over time. Mach had some pretty forward-thinking ideas about that. It sounds like he kind of anticipated some later theories about how science progresses.
He did. He was a real pioneer in that way. He's seen as a precursor to what are called selectionist accounts of scientific change. His idea was that new scientific ideas, and that the variation in thought, we don't consciously control that. It's not like we can just sit down and say, okay, I'm going to come up with a new theory. It's a more undirected process, maybe influenced by things like imagination or even chance.
So it's not all logic and deduction, right? There's
Right.
this element of randomness, and then it's up to scientists to sort through it all.
Exactly. We can't just create correct new theories out of thin air. But our minds, they do play a role in what happens next, the selection process. So scientists, they look at the ideas that are out there and they favor the ones that fit the data, the ones that make sense with what we already know. And it's interesting, Mach was actually pretty tolerant of non-scientific beliefs. He thought that diversity in thinking, it's actually valuable because sometimes, those ideas that seem kind of out there, they can end up being really useful down the line.
That's a pretty open-minded view for a scientist, especially back then. And you mentioned that he kind of foreshadowed some of Thomas Kuhn's ideas about scientific revolutions. How did he do that?
Well, Mach, he applied Gestalt principles to scientific thought itself, and he really emphasized the importance of looking at the history of science. And that really anticipates some of Kuhn's key ideas, like paradigms and paradigm shifts. Mach's understanding of how our own cognitive frameworks, our assumptions, they shape how we see things, not just the physical world, but even scientific theories, that's very much in line with Kuhn's work. Kuhn's idea was that scientific progress, it's not always this smooth, linear thing. Sometimes there are these big shifts, these revolutions in thought.
Okay, so last but not least, we got to talk about Mach's critique of Newtonian physics and his famous anti-atomism. This is where he really clashed with some of the big names in physics. So what was at the core of his objections to these ideas, like from a philosophical perspective?
Well, Mach's analysis of Newtonian concepts like absolute space and time, that definitely had an impact on Einstein and relativity. But philosophically speaking, his anti-atomism, that's really interesting. It wasn't just that he doubted atoms existed because we couldn't directly see them back then. It was deeper than that. It went back to his whole view of science, this biopsychological approach. He was wary of these theoretical entities that couldn't be like directly linked to sensory experience.
So the concept of atoms, it felt too removed from that grounded experience-based science that he was all about.
Right. He was always suspicious of introducing ideas that seemed to go too far beyond what we could actually verify, and that's what led to those famous disagreements with physicists like Boltzmann, who was a big proponent of the kinetic theory of gases, which relied on the idea of atoms. And later on, he had this back and forth with Max Planck, and their debate was really about a fundamental question. Should science aim for a description of reality that's independent of us, based on these universal constants, or is it inherently tied to our human way of knowing, to our biology?
Good questions. And even as the evidence for atoms got stronger, Mach still held on to some of that skepticism.
He did. He remains skeptical about the immediate reality of atoms. He always prioritized what he called the freedom of scientific thought, not just accepting dogma, especially when it came to things that we couldn't directly observe. He thought it was important to stay open, to be critical, to not just jump on board with theoretical entities that were still pretty indirect in terms of our actual experience. And this stance, it's actually really relevant to philosophy of science today, to discussions about scientific realism. What parts of our theories are they really reflecting reality, or are they just useful tools for understanding and prediction?
Such a thought-provoking thinker, Ernst Mach. So for our listeners, for all the philosophers out there who've been with us on this deep dive, what are the big takeaways from Mach's work?
Well, I think for a philosopher, Mach offers this really integrated and challenging perspective on how we know things, on the very foundation of knowledge. He's saying that even the most abstract ideas in science and philosophy, they come from our biology, from our psychology, from how we interact with the world. His focus on experience, on adaptation, on this idea of the economy of thought. It gives us this unique lens to look at epistemology, at metaphysics, or maybe Mach's anti-metaphysics, at the philosophy of science. It's all connected.
And his ideas, they're still relevant today, right? They're still sparking debate.
Oh yeah, for sure. His critique of metaphysics, his insights into how perception works, his evolutionary take on science. These are all things that philosophers are still grappling with. And even his skepticism about unobservable entities, that's still a big topic of discussion in philosophy of science.
So to you, our philosophical listeners, as you continue to think about Ernst Mach and his work, here's something to ponder.
Yeah.
How does his idea of a biologized a priori, how does that challenge or maybe even add to current debates about innate knowledge, about how our minds were structured? And what about his emphasis on the economy of thought? Does that fit with how philosophers today think about choosing theories, about simplicity and parsimony in scientific explanation? These are just some of the pathways that Mach's work opens up. Really rich and influential stuff. And we encourage you to keep exploring, dive into his writings, check out the secondary literature. There's a lot to discover.